In this video, we're going to show you some basic concept that is associated with what we call discrete random variable. So first of all, let's define what discrete random variable is. A discrete random variable is a variable. And what's a variable? It takes on different values. But what makes it random is the fact that each value is associated with a probability. So a discrete random variable is a variable that takes on different values, finite number of values, or countably infinite number of values according to a set of probabilities. So let's just focus on the simple case where the random variable would take on only finite number of values. So let's look at an example. The first concept about the random variable can be seen from this example. Suppose we have a random variable, x, and as we said, x is a variable, so it takes on different values. So in this case, it takes on 6 different values, -6, -2, 0, 4, 10, and 14. And it's a random variable because of the fact that each values it takes on is associated with a probability. So we use fx as a notation for probabilities. So the probability of x equal to -6 is 0.2. The probability of x equal to 0 is 0.08, and so on. And x is a discrete random variable because it takes on, in this case, finite number of values. So x is a discrete random variable because it takes on finite number of different values according to a set of probabilities. And the first property of this is the fact that the probabilities should add up to 1. So for example, suppose I do not know the probability of x equal to -2 and we want to find that. How do we do it? Well, we know for a fact that the probabilities of the fx, the probabilities, is sum to 1, right? So we can actually use that. So we can say a, if we want to find a is equal to 1 because it add up to 1, minus the rest of the values, in this case 0.2 plus 0.08 plus 0.1 plus 0.15 plus 0.25, right? So let's just calculate this by just copy and pasting. So let's just copy it here and see what it is. All right, so something wrong with this because it's 0.25, not 25. All right, and so we can just fix this number, 0.25, and so therefore the number is 0.22, right? So this number is 0.22 because of the fact that the sum of all the probabilities associated with a random variable should always equal to 1. So that's the first property that we should know about in relation to a random variable. The next concept that we want to talk about is the expected value, EX, or the mean of a random variable. So as the name implies, the mean, which is really an average, except that the average is a weighted average and the weights are the probabilities. So let me just put in the probability that we found here. The probability we found is 0.22. So according to this table of values of x and its associated probability, we can actually find the average values. Now, the table here is called a probability distribution function, or is also called a distribution function, and is common to have other names as well, like probability function. So how do we find the average value? The average value is denoted by E bracket X, because it's called expectation. It's also the notation mu, and the calculation is the average of x, and it's weighted by fx, which is the probability. Now, the summation is basically the sum, right? So in order for us to calculate this expected value, the best way for us to do it is to add another column in the probability functions, x times fx. Okay, and what we need to do is to calculate x times fx for each value of x, and then we sum it up. X times fx for each value of x, and then we sum it, right? So in Excel, it's actually pretty convenient to do that. We say A20 times B20, right? Sorry, I put it like so. Actually, A20 times B20, and so the number is 0.12. Negative 0.12. Let me just make it in 2 decimal places, and then what we can do is we can just copy the formula to the rest of the cell, and that would be the value associated with x times fx. And so the average value, mu, or the expected value, is just the sum of all these values, right? So in Excel, what we can do is we say sum of C20 to C25. Okay, and so the expected value is 3.76. Now, this average value, this expected value, is not the same as the arithmetic value because of the fact that this average is weighted by the probabilities. So if you sum this, if you run the average of this, the average is not going to be 3.76. Now, so the question becomes, what does this number mean? Well, the number actually means this. First of all, it's an average. So we can say on average, right? The expected value, the average is, on average, x is 3.76. But this is only true according to the given probability. So if we change the probabilities, then the expected value will also change as well. So what we have to do is we have to qualify that not only is an average value, it is only true when the probability distribution function is given. So we say according to the given probability distribution. All right, so both of these are important. So the first qualifier, this is an average value, and the second qualifier, this is only true according to this given probability distribution. Both of them has to be necessary if you want to provide an interpretation of this value. Now, at this point in time, I'd like to give you an example. So let's look at an example, and this is the view example that we see in many places. And this is a advertising by a supermarket in the Vancouver, BC area. It says here, if any players from a Vancouver, Edmonton, Calgary, or Winnipeg hockey player that score 5 goals in a game, someone would win $1 million. If the same player score 4 goals in a game instead of 5 goals, then the lucky winner, who's been drawn randomly, would win $100,000. And there's also great prizes for every goal. Now, the great prizes for every goal promotion is pretty straightforward, so we're not going to look at the issue. What we want to do is to see how much actually would cost a company to run a promotion like this, right? So in a hockey game, right, we're talking about the hockey game. In any hockey games for these teams, if any player from these teams score 5 goals in a game, 5 goals in the same game, the lucky winner that has been drawn randomly win 1 million. 4 goals, 100,000, right? So it looks like there's a lot of money that you need to put into the promotion. However, from a probability standpoint, the cost of this promotion is not that bad, right? So let's just summarize these promotions by just taking on the example for the Vancouver Canucks hockey team, right? So so a Save on Food customer who registered as randomly selected, right? So first of all, someone is selected for the game, and if a Canucks player score 4 goals in the game, the customer selected will win $100,000. If the Canucks player score 5 goals in the game, the customer was selected would win $1 million. So how much would this promotion cost the company on a per game basis? So let's try to figure this out, right? So if we define X to be the amount payout for each game, then X is a random variable. Why X is a random variable? First of all, X would take on 3 different values. The first value is $1 million, right? So there is a possibility that the company has to pay out $1 million. There's also a possibility that the company would pay out $100,000. There's also a possibility that the company pay out nothing, right? Because if no players in the game score 5 goals or 4 goals, then the company would pay out nothing. The secret, of course, is in the probability. So if you look at the probability associated with X equal to $1 million, that means what is the probability that someone from a hockey team can score 5 goals in a game? Well, that actually is pretty rare, right? So if you look at the we look at the record in NHL, approximately 60,000 games in the past 20 years, only in 4 games that a hockey player can score 5 goals in the same game, right? So the occurrence of someone scoring 5 goals in the same game is pretty rare. So if we use that to estimate the probability of X equal to 1 million is equal to 4 over 60,000, and that probability is 0.000067. On the other hand, scoring 4 goals in a game by the same player happen more often. Now, unfortunately, we couldn't find any statistics that is definitive. So I'm estimating that the probability is 1%, and obviously we can actually juggle around and see what that, if we change that number, what would happen to the cost itself, right? And so assume that we have for each 100 hockey games, we have 1 game that has a player who will score 4 goals, which is, I think is high, but let's assume that is the case. Then the probability of X is equal to 0 is just 1 minus that, right? Because if nobody scores 5 goals or 4 goals in the same game, then the company does not have to pay anything, and the probability is just 1 minus that, and in this case would be 0.989933. So X is a random variable, the discrete random variable, because X would take on 3 finite values, and has a probability associated with each of the values. Now let's calculate the expected value. Let's calculate the average, right? The average is the amount that the company has to pay, right? So if you take X divided by FX, which is in this case is $60.67, that basically means that on average is costing the company around $67 a game, if the probability is right, to underwrite this price. On the other hand, it's costing the company about $1,000 to give a price of $100,000 if someone scored 4 goals in that game. And of course, if nobody scored 4 goals and 5 goals in the game, it would cost the company nothing. So if we add them up, which is really the average in this case would be $1,066.67, which is obviously not as high as we would expect. So the promotion sounds really impressive. The actual cost to the company may not be as bad as you would think, right? So what's the interpretation from our perspective? So first of all, this is an average value, right? So average means that if you do it for a long time, this is what happened. On a per game basis. The company may become really unlucky. I mean, the first game in the season, someone can buy clothes and the company has to pay out $1 million. But if we do it over a long period of time, this is what the company is going to have to pay out, right? So the company needs to pay $1,066.67. And this is only true according to the given probability. That means that if the probability that we estimate here are wrong, then obviously this number would be wrong. So we would say according to the given probability or probability distribution. It's the same thing. Okay, so that's the interpretation of this number, and it's very important for us to know about the interpretation to make sure that we understand what the numbers mean. Now, the final concept that we want to go over is the variance calculation for a random variable. The variance is just like another type of variance concept, is about the variability of the random variable around the average. So the formula for that is the variance, we use Vx or VARx or sigma square is equal to the individual values minus the mean, right, minus the average square. So this is the individual values and the means difference, but some of them are positive, some of them are negative, so we square it to make it all positive, and that number is weighted by the probability, and you sum them. So this is again a weighted average of the square deviation of the individual values around the mean. Now, this is really complicated calculation. So in order for us to do that, we break it up into pieces. So the first thing we need to do is, of course, is to calculate the mean, right? And then once we calculate the mean, we calculate x minus the mean. And then we calculate x minus the mean square. And then we calculate x minus the mean square times fx in a table. And then at the end, we sum them. And once we finish calculating the variance, a lot of times we also calculate the standard deviation, so STX or sigma. STX is basically the square root of the variance of x to bring everything back into the same scale as the random variable. So as I said, in order for us to do it properly, we should always use a table and we can track everything that we do. And this is particularly convenient if we are doing it in Excel, right? So the first thing that we do is to calculate the expected value, which is x times fx. So we do a7 times b7, right? So 6 times 0.2, which is 1.2, and then what we have to do is just copy, or we could just drag it, right? And so that is, let's make it 3 decimal places. So the expected value, of course, is equal to the sum of this, right? So sum of C7 to C10, right? So that is the expected value, or the mean, or in fact the weighted average of the random variable x. So the next step then is to calculate the individual difference and then square it, right? So the individual difference is the x minus this value, right? So how do we do that? We say A7 minus, and we want to always minus the number, so we want to copy the formula, so we use the absolute addressing. So column C, $12. Right? So let's just check. 6 minus 1.65 is equal to 4.35. And we can actually now track it and calculate this. And you want to check the second one is 3 minus 1.65. Of course, it's equal to 1.35 and so on. So it looks like our calculation is okay. And the next step then is to calculate not only the individual deviation from the mean, but to square it, because some of them are positive, some of these numbers are negative, so we square everything. And so that's easy enough. We do D7, and square is just square of this number. And all we have to do is to copy to the rest of the cell. And that is x minus ex squared, or x minus mu squared. And the last thing we need to do is to take this column weighted by the probability. The probability is in the B column, right? So we do the E column, E7, times the B column, B7, right? And so if you look at this number, this is equal to this number weighted by the probability. And all we have to do is we drag it down. And let's look at this one, right? This one is B10 times E10, right? So the individual deviation square times the probability associated with that, right? And the variance in that case then becomes the sum of the above, right? So F7 to F10, right? So that's the sum, and so that represents the summation notation in the formula, and that's the variance. So in this case, the variance is equal to 10.028. And typically, we actually take the square root of that. So how do we do square root? In Excel is SQRT and F12. And voila, we can now find out that the standard deviation is 3.167. And we don't usually calculate these numbers a great deal if we are studying discrete random variable. This standard deviation does give us a sense of how the variable, the various values that x would take on in relation to the probability. So we cover the fact that the probability, the sum of the probability of a random variable has to be equal to 1. We cover the concept of the expected value and the interpretation, which is actually really useful in evaluating various scenarios. And we also talk a bit about the calculation of the variance and the standard deviation. And that covers the basic concepts that you need to know for discrete random variable. And hope that you enjoy it, and I will talk to you soon. Bye for now.